yesterday, let me come back a little bit. So maybe I know that some other participants will be probably joining us, and we are looking forward to that. But those who are here, I would like to know one or two key messages we kind of started yesterday with the context, and so maybe started studying. What do you think we had discussion? What was the key messages from yesterday?
So, in my point of view, I have learned about the level of scope, the scope 1, scope 2, scope 3. In that way, we can calculate the amount of emissions taking from start to end, that is from scope 1 to scope 3. And one key information I have got yesterday, that is the amount of CO2 that is being released by methane and nitrogen N2O and SF6. That we regularly come in contact with industry. As I am working with steel industry, so NOx and SOx emissions are part of the waste emissions which takes place, and in that we can able to calculate the amount of CO2 it will be generating. So that are the key points I have learned yesterday.
Fantastic. Thanks a lot. Very good brief. Sorry, madam, what's your name again? Can you remind me? Sorry. Dipali, you are Dipali, right? Okay. Tell me what you learned yesterday. What was new? Anything new? One, two. Nothing new? Nothing new? Right, okay. What about you?
Actually, we discussed about sustainable development goals. Then we get into carbon footprint, LCA, stop environmental problems, and then we discussed about decarbonization and why now. And later about steel producing countries and their why they are producing and how they are producing. That's about that. And next, this covered
What is it? That's good.
so many areas.
And you are
so many areas. And I am only telling what we have not covered.
Good. Thanks. Yeah. That's good.
Alternative and renewable energy sources and hydrogen demand and about fossil emissions, gas, and LCA of various hydrogen production technologies.
Thank you so much. I think you have covered most of them what we discussed. What's your name again? Remind me. Sorry, I was Samishta. Thanks. And good morning. Please have a seat. Yeah. So you don't have to stand. Just please tell what you have. Anything you remember from yesterday? A remarkable highlight.
Briefly, what is decarbonization and what are the ways to measure decarbonization?
Fantastic. That's right. Okay. What is decarbonization? That's right. Here? Here. What?
Yeah, good morning.
Yeah.
Yesterday, discussion we have learned about the various kind of sources, replace of coal, like green energy, biofuels, and solar wind differently. And how to produce green energy and clean energy. This is a new thing. And second thing is we have explored all the area which is in here, means Burnai, everything you have on your PPT. That's right.
Thanks. Thank you. Sounds like it got interesting. Found interesting. Good. Yeah. So I think that's what I do. I share my experiences, various places. Actually, in the morning we were discussing that. I think also Shukla and Asarya sir were there also. That we were talking about experience. Yeah. We have so much experience in the plant. You guys have also, which is a lot of academic. We lose that experience because we are more in the theory, but not so much actually day-to-day running plant. So I think we are just recapping from yesterday. So please tell, you are in the right spot now. Tell, what was the highlight from yesterday?
Yesterday we came to know what are the scenarios in the world and where India is actually are. Now we are looking forward that what is the real picture.
That's right.
And commercially
Available technology. Is this any Intel? Yeah.
This is commercially feasible or not?
Yeah. Even though in Bengali there is a called Aladdin's Charag. Aladdin's Charag. You know that
Aladdin's Charag is
lamp
in India
of,
also.
yeah. So hopefully we'll have some solution. In the fact, yeah. So any remarkable thing from yesterday? we have covered quite a bit.
Yeah, that you were discussing the same thing in the car while we were coming, that this is something, a new perspective we are looking at. We have not thought in this kind of line while we were working in the industry, and how to calculate this kind of things and take some impactful decisions in that direction.
Right.
We are always concentrated in our day-to-day work, and somehow the ways that the world is going in a different direction, and changing so fast in this short period. So yeah, this is
I
something.
think we should keep updated and also do that ourselves also, isn't it? And the gentleman over there, anything yesterday you learned or?
So I got to know about some full forms. That is ECWW,
Thank you. So that's
GRAP, GRAP, PSN. So these are the things I've studied down.
Yeah, I wish I have some gift for you, that some chocolate maybe or something, but anyway, that ECWW, remember that, yeah, energy, carbon, water and waste. And Sarya sir, you have a lot of experience, please share one or two thoughts, what you got from yesterday, or what you got together. Yeah.
Of course, this ECWW is a new concept to me, so I learned about it. And then the stratification of critical and strategic approaches like materials, rare earth materials versus magnetic materials, which are strategic. And then the Australian pathway towards hydrogen technologies, especially the case of Renai, and then how Australia is leading from the front technological development of hydrogen things. Then how the carbon footprint calculation has to be done. I mean, it was a brief outline about how do we do and then frameworks. So it has been a good journey.
Thank you so much. So, good morning everyone, those who joined late, that's fine, thanks. Tomorrow please come on time. We just discussing what was the recap from yesterday, so most of the people covered that, we gave the context, decarbonization, how to calculate, what is the CWW, so most of the, I think, now seems like we are on the same page to start the real stuff, right? And everyone really motivated and enthusiastic, I guess. Anyways, I had a good breakfast also. We had a good chat with Professor Shukla and Acharya. I hope Professor Shukla at some stage join. He's very wealth of knowledge he has got. He worked in DSP, I understand, and now IIT Academy. So in the back, you can hear me well, right? Everyone? Okay? In the back? All good? Thanks. So today, what I would like to do, so because whole, I know you are producing power, every day operating, you are very good at that. Those who are working in the steel plant, you are good at making steel. So I'm not going there too much. What I'd like to do, although I'm saying that technology to reduce GHG, greenhouse gas emission in the steel industry, but I will be covering mostly the theoretical aspect of LCA, foundations. What is LCA? What is life cycle assessment? How to calculate? What are the standards? So I think we need that context. And then I'll show some calculations and we can do some hands-on activity down the track. But in the next couple of days, I believe, but because just we finished one day. So one day generally I do set the scene, and I think we are all motivated that it is a big challenge and it's not an easy job. It's complex. Yesterday saw so many variables playing on the sector. So I think let's go into a bit more. So, but before I go, I thought a bit of globally. I talked about Quad yesterday. I think you mentioned that one. So many countries are working hard. So this, I'm leading this program. It's called, you can see that one. So sorry, I think I need to stop this one somehow. Maybe I'll just come in this. Just give me a second. Otherwise it will be disturbing. So I will so I will say flight mode. Press easy. So I'm not getting any disturbance. Alright, good. So I think this is my 23-year career. This is one of the things I'm most satisfied, and I think this is I would say I enjoyed most from this project, and that is called India Australia Minerals Scholar Network. I ran that for the last 3 years. So 23, our Prime Minister Anthony Albanese, still there was an election and he continued. So he came in Australia. He came in India. I think there was in Gujarat, there was a big cricket match on something like that. That time happened, and so two Prime Minister, Australian and Indian Prime Minister, they made a statement, and that came about India Australia Minerals Scholar Network, and they say Prime Minister looked forward to cooperation with India through the India-Australia Minerals Power Network to develop an ecosystem of technical talent across both nations with expertise in green steel and critical minerals. So that's what we're talking about. The network will support India's emergence as a renewable energy manufacturing powerhouse and Australia's goal of becoming a renewable energy superpower. So we call it, so India as a manufacturing powerhouse and Australia, we call it renewable energy superpower. And why? Sorry. Can you hear? Oh, the sound. The sound is going now. Hello? Can you hear me now?
Yes.
Yeah, good. So what I'm saying is that our Prime Minister likes to portray Australia as a renewable energy superpower. And I showed you that renewable energy we have got solar, wind, etc. On the other hand, India has a lot of advantage in manufacturing. So two nations create a nice cooperative, mutually benefit we can do. So under this program, what we did senior PhD student to visit and research at CSR laboratory. 1 year, the Prakash completed, a couple of other students I can name. Postdocs in India, so several postdocs are going on. And they are working in India, but they can work with us. It's a kind of building team. And we sort of going through that one. Joint conferences, we had some events. Actually, next year we are running an event in February in Australia in Swinburne University. It's called Australia AIST, probably Australia Association of Steel Industry. So that's the Australia New Zealand chapter is having a conference in Swinburne University and will be supporting some Indian participants there. We will be providing some financial support also. So if you know anyone who's good quality speaker and can tell about industry, can promote Australia relation, I'm happy to talk to you. And in workshop and short courses like these, even we had another short course before in collaboration with our collaborators like Dugabu. And PhD students in Australia. We have got a number of PhD students working and mainly green steel and critical minerals. So we have built that team now in various IITs, NITs, now south, east, west. Actually, IIT Bombay, I'm not sure whether I could like location, but we have got a project looking at Indian map. So they will similar this map. They will be determining what is the green steel potential in terms of cost of production and matching with renewable energy in India. That we have done that for Australia. Same exercise we will do for India. So I'm looking forward to the conclusion of that project. IIT ISM looking at scrap quality on electric steel making, electric arc furnace. So that kind of work. One is student, what is that? Other one, Dugabu, obviously they're working on hydrogen plasma. So number of institutions we are working on and developing. Professor Shukla should be here in probably the next couple of days. IIT Madras is looking at the ethite behavior under reducing conditions. So a lot of work. Again, I'm focusing on green steel. Some of them are critical minerals. That's not relevant here. But we are looking at again CO2 emission reduction from the steel industry. So as we yesterday saw, it's not easy work. It's challenging work, but there's also opportunities. So we need to look at through R&D, developing talents, and so that's the objective of this work. So I think projects usually negotiate based on proposal fit for partnership because our objective to develop talents. Australian University is strong in hydrometallurgy, biometallurgy, batteries. We have targeted them. So sort of several PhD students working in various Australian universities. Indian student, we pick them, full scholarship we get, and they are working on that in Australia now. And yeah, team of experts, obviously it is required. We know that one is a different skill set we probably need to be equipped with. Even if you are working in the current industry, still you need to know what is happening as Alpha said. So anyway, so if you know anyone, we have got maybe 1 or 2 proposals still left, but most of the funding done. It is finishing June 2026, but beyond that, if there is more funding coming, and I don't know what will happen, but there's a chance because we have built a good network and good team in Australia India platform. So yeah, happy to discuss more. I think through this program, I mainly connected with IITs, NITs, CSR labs, but not so much with the industry. I'd like to get more industry because industry is always keeps us on track and the practical, realistic. We feel like if there is research has no application, what's the point of doing that kind of research? Maybe our colleagues, academic colleagues, professors are more interested, but I'm with the application. All right, so you can explore more from there. So just let's move into that program now. So that's today's talk. Obviously, what are the technologies? So this is a piece of steel. I think that Swedish companies, they are making that green steel. They are saying hybrid technology. So that's a hybrid steel. So there are technologies, but that's not necessarily steel making. That's downstream, refining and etc. And there's a big kind of what I would say publicity about that. Professor Shukla is here. Thanks for coming, Professor Shukla. So he's got wealth of experience in the industry and also academic. So anyway, so that's I just wanted to mention it. So now when we discuss about green steel, so how we do that, various people say different ways, and obviously yesterday we discussed a little bit about that. That CO2 emission reduction from the steel, essentially the product should have no CO2, and not only CO2, I would say ECWW footprint, the energy, carbon, water, waste footprint should be low. At the moment, everyone know about carbon footprint. That's why we are more interested, and it's more popular term. Everybody in the industry, in the public, in the government, they know. But it's beyond. We need to look at beyond carbon footprint, and that's my definition. Is that it's not only CO2, low CO2, other impact should be also low. Makes sense? Okay? And that's you agree, right? Now that this is not only maybe two steel plant, there one is CO2 low, but something else is high. How do you say that from green steel? So that's the things we need to know. So actually we are looking at the briefing, talking about the critical minerals, and sort of drawing your attention here. So from Indian perspective, some of the world's major steel producers have started trialing cleaner steel making processes that use hydrogen as a substitute for coking coal. But traditional blast furnaces are projected to remain widespread for many years to come, and that's what we discussed yesterday, right? Requiring the industry to examine various other options to reduce carbon emissions. So still focusing on just carbon, okay? So not completely CW. So Rajiv Mukherjee, some of you might know here, I'm not sure. Tata Steel's Vice President of Strategic Procurement yesterday said that the company was working on several decarbonization pilot projects, including carbon capture. That's one way to do that when we talk about technologies. Hydrogen-based steel making, and also biomass steel making, which Abash and yesterday we discussed about. So now, looks like I think we had scope colleagues, right? Some scope colleagues were from that similar strategy you are having.
Yes, we are working on carbon capture right now, but not currently on hydrogen.
Hydrogen is the long way you said.
Actually, there is a new plant coming in ISCO Steel plant.
Yes.
The new furnaces, there will be a provision for injection of syngas, and
Right.
CO and hydrogen.
Right.
As sir was telling yesterday,
Right.
we are making a provision for injection of syngas, so that at least the carbon footprint goes down.
That's right. Yeah. And also obviously biomass may be relatively maybe another low-hanging fruit, but we had a discussion about that. To be honest, I'm not a big fan of biomass because of the enormity in steel mill. How much biomass you need to do? We have that one processing that. Actually, I did my PhD in drying, biomass drying. So I think one of the bottlenecks is drying. We assume biomass is biomass, but biomass is not biomass. You need to cut it, chop it, process it, dry it, and drying that much biomass is not easy task. So how do you manage that amount of millions of tons of coal we use in steel making? Suddenly replacing it with biomass, I don't think it's easy. Man might be, but other people might have different opinion. So far, okay? Anyone question or comment? All good? We're on right track? Alright, so what we're talking about, so that's actually the Sabash's diagram. I wish Sabash is here. So what we're doing, we need to calculate, I said that LCA, CO2, carbon footprints. To do that, we need to have this kind of block flow diagrams. That's what we started with, and boundary. So yesterday we discussed briefly a little bit. Actually, next chapter I'm going more into detail of LCA. So that's how to do an LCA. So if you look at traditional this kind of group, so you've got iron ore. Obviously, you know that ingredients to make steel is iron ore. And yesterday I showed that Australia produces significant amount. That's why we had to look at China makes 1 million ton of steel, and majority of the ore comes from Australia, Brazil, maybe some South Africa now, or other African countries. New mine, I think opening up or something in somewhere in Congo. I don't remember one of the African countries, Chinese investment. I believe that there will be resources, and obviously India produces a lot, China themselves have a lot, I don't know, maybe a bit lower quality, so that's why they look for Australia. But Australia has very good quality iron ore compared to the resources around the world. And so iron ore, that goes, we have to mine it obviously, and then crush, screen, essentially that's what we discussed about oscillating and sheet metallurgy. So we kind of dig it to
year. Fines from fines pellets are produced.
Right.
From now, actually the technology has shifted. It's iron ore is merely used below 5 to 10% maximum.
That's right.
Yes, because mostly pellets and cinders, the prepared burden is more than 90% right now.
Right, right. So that lumps and fines too I'm dividing. Lump directly can go to blast furnace, fines may be sintered or pelletized, maybe that's another option, fines can go to pelletized. Right? So then that goes to the blast furnace, obviously big cooking plant, and anything goes down and goes down, that's it, isn't it? Like we eat and go, that's the same philosophy. And you get pig iron, and that goes to the oxygen furnace, and then you get steel. That's the deal we are here, isn't it? Now, what's the CO2 footprint of that at that point in time? Or is it WW? How do we calculate it? Go all the way up, right? Because that's the starting yesterday, Mr. Micrometer, and the boundary there. Start to kind of gate, cradle to gate. We are not talking about cradle to cradle because steel maybe go to the car, or there are a lot downstream manufacturing process, once end of life, car can be recycled. That's another story. We are not going that far. We are finishing here. Cradle to gate. Remember that down boundary? So I will talk a little bit more on the LCS side. So now the sinter plant, unit coke is a kind of input, I believe, and the sinter runs the blast furnace. Actually, I think it's actually very deep, kind of large deep that one. Not a lot, everything like blast furnace has got other inputs, right?
Yes,
You
the
have got coal,
main coke is missing.
you have got PCI, right?
So the main coke line is missing.
Coke line is
Blast
missing,
furnace.
and also you have got dolomite, I believe, right?
No, actually, sir, it has changed. Means we do not use raw flux right now.
So you
So
use
since we are using a prepared burden that is
like
sinter and pellet,
then
so the pellet is with low basicity.
that's right. So
And the
already
sinter has got higher basicity. To eliminate the need of any raw flux inside the furnace. It will also reduce the fuel rate in that
that's
case.
right. Okay. So in that case, if you have lump, you just use dolomite some
Yes,
plus,
yes.
right? That's the holding.
Yes.
Cold
You have
technology.
got good quality lump, you could do that.
Yeah.
Now that you
No.
have that luxury. Yeah. So see things are changing so quickly because less resources, low grade resources. Even in Australia, so I said when I started my career, I used to look at that 200 million ton, 250 million ton was the Australian production total, 3-4 mines, 3-4 companies. Parabardu, I think maybe our Pilbara is here, and this is one of the best iron ore resources in the world, as you know. So you've got, I think, 28 billion kind of good quality resources, and there are, if you go below some quality, there will be. So even say now we are producing nearly 1 billion ton a year. So in 28, 30 years, we'll run out that resources kind of. And then maybe we need to look at the low grade, high phos, high silica, high alumina. So then that adds complexity, isn't it? So it's not necessarily what we used to do. We can continue to do that once we need to look for new technologies. So that's one. So now, and also DRI, I think, so DRI plant, you obviously pelletize that DRI straight and DRI can go to EAF. By the way, I don't think DRI can straight go to EAF, can it? You have to have another step or not? Another furnace?
No.
It can be,
DRI
DRI
goes to
can be.
EAF.
So but another thing people are talking about, that low grade resources, maybe I think Jim Brooks is a proponent of that electric furnace, another furnace they include to upgrade, and then you can have a proper kind of low grade iron ore DRI and low grade DRI essentially, and then another furnace in between, and then EAF in next steel. So there are number of ways you can configuration you can have, and obviously you are working on rotary hearth and other. There are many technologies which is under development, not yet commercialized probably that big. DSP has got, or ASP has got that plan, you said, that rotary hearth. Can you explain a bit of, to the audience rotary hearth furnace? If anyone doesn't, I mean, some of you I know very well, but
Actually, we have one pilot plant is there in ASP. It was a joint project between IIT Kharagpur and ASP. It is an industrial steel project. So, rotary hearth furnace is like what happens like in case of DRI making. Hardness is moving condition. Therefore, the calculator which is required some strength. Otherwise, it will produce fines. But RHF furnace requires very less strength. Like if you agglomerate the coarse particles also by addition of some binders, it may only the DRI. You can produce the nuggets. Nuggets is actually the almost the purer form of metal, where the slag is lead out from that material. Which generally in case of DRI, what happens? The gang materials is entrapped inside the metal materials. Okay. Therefore, if you can produce the nuggets, nuggets will be just almost say liquid state. It will reach out almost the liquid state. Then what will happen if the lower density of the slag, it will come. Therefore, you can get the almost pure type of metallic materials RHA.
After that, the slag will be chipped
Out. It will be just if you screen it, vibrating screen if you use, then metal and slag particles.
It's a kind of basic smelting, isn't it? And
Almost you can get that pure on metal. The benefit is like pyrophoric in nature. DRIs, you cannot store it out. If it means in normal weather, you cannot store for a long time. But if you can prepare the nuggets, it will be like the metal. Therefore, there will be no
storage capacity, longevity, etc., handling, etc. So there are some advantages. So because in this session we are talking about technologies to reduce GHG. So there are some technologies and other technologies. So yeah. So sorry, anyone? Okay.
So this rotary hearth furnace is in operation.
Oh, sorry, Dr. Asaria sir. Yes, go on.
RHF is in operation in POSCO, Poem, correct?
Yeah, it's possible. But here, ASP having a like pilot type of thing.
So we can do some experimentation also.
Good.
What
Excellent.
is the capacity of Pallet strip?
Maybe a few kgs.
Kilograms scale, huh?
Yeah, some
Several
kilograms.
kilograms.
So actually, I think there is one RHF furnace for large scale investigation.
It is in IIT.
But that is also having some 1 or 2 kilogram capacity.
Yeah.
And I think this is 10 or 15 kilograms.
So right, so I think we can. So the point is that there are technologies probably people working on. Some of them are low TRL, some of them are reasonable high TRL. You may heard of so anyway, that pelletization, EAF, steel, then pelletization, DRI, EAF, steel. Here we have not included hydrogen core. We have not included even very hard. We have not included another one is called ice melt. Have you heard of that? In Australia they have a plant actually. They had 800,000 ton plant they set up. It didn't work out. There's a direct top plants, smelting with low grade resources. Actually, Cyrus says on a lot development.
Tourism is secondary steel making.
Which one is that?
Ice melt process.
Ice melt. Yeah. So that's kind of EAF, but in a different direct top submerged lens based smelting. But apparently that has got some advantage in terms of maybe CO2 emission. I'm not sure. So now, I think it's, so basically what my question is that, so this is, I'm not interested about steel making, I'm not that expert. My interest, what is the ECWW footprint here, what is the ECWW footprint here, and also what is the cost, the typical, capital cost, if we have conventional DRI here, what is the capital cost, what is the capital cost, what is the operating cost, and then if we can plot various scenarios, and obviously, so how do you understand or how do you determine that one? If I have got steel colleagues, how do you determine the cost of steel? It's just all the inputs in
All the
All the
inputs, all the inputs, all the
amount
resources,
of
the fixed cost.
fixed cost,
yep, the plant, capex,
fixed cost,
etc.
variable cost.
How many people are working, salaries,
Yes, yes.
other admin, etc. You add up, right? That's the way. Actually, Avash has done that one. We have not published as yet, but we have got 3 different routes, 3 different technical models. That's how we do that one. So, capital cost, operating cost, yes.
One thing is missing actually. In India we have another thing also, induction.
Induction furnace, yeah, that's another technology, right? Yeah, it's relatively small compared to big one, big is, I guess, yeah.
But in India, almost 1/3 is coming from induction.
So that's medium scale, medium small industries. There's an MEs. That's interesting one, and that's the one part is it's a significant contribution. So we shouldn't forget them, right? They have the lifeline of the industry, and we always talk about Tata or JSW, or because that's where you get sale. But there are others, there are small players, and we need to be really mindful of them. Actually, I mentioned with someone yesterday, one of the colleagues, I think that Qazi Nazrul Islam, although Mazumdar, because we have got one project, Rishikesh Mandane yesterday probably I think we mentioned, he's going to look at the SMEs in India and in a map he will probably the big, small, and all the hubs, small scale. He will look at that and he will what is the how much production. We already developed a model, very nice now. What's going input and what's the different types of second, not only steel but also other downstream products they're producing, isn't it? Various types of rods and bars, etc. So what is the ECW revenue of that? He will determine that based on the data, real data, and then at the moment he's modeling that, and they will compare so it, and then we will look at the what are the where are those impact coming from and what is the best way to reduce that. So it's a good work. I'm looking for that, and Rishikesh is very thorough. We have started already a lot of literature. Working with Terry in Delhi, as you know, some of you. He's working with another couple of institutions. I know he has got old connections. And now I think I'm going to introduce it Urban Rotunda so that he can come to Asansol, because that region has got lots of. But he's looking at Gujarat, Punjab, because he's a Punjab. I think he's from, I can't remember where he's from, but he has got connection in the north part. I said, go to the east also. You need to look at the street, there are a lot of plants here around, isn't it? Yeah, so maybe he will come to Durgapur also at some stage. So I think that's one. Cost is not a big deal, you can handle very well. Now, if we talk about ECWW, particularly CO2 footprint, even it's not difficult because you know how much smoke is going, how much energy is going, you can calculate. But if you think about the other indicators, then that's tricky, and that's where specialized technology, specialized methodology, life cycle assessment, software, skills, those sort of things come. And I think I would like to draw your attention that engineers need to be aware of that, sustainability and those calculation methods. Does that make sense so far?
So the carbon emission is only calculative or real time?
Okay, so you can estimate. It's you can estimate kind of. It's not 100%, but plus minus say within 10% accuracy, because you know exactly what is going in and out kind of. That's all as well as bread and butter for chemical engineers. So not a big deal. But sometimes companies measure. They can have sensors and you measure and then calculate and then cross check and get some calibration, and then you can use that. That's another option. But many of these data are already measured. That's why it's called data quality. So data quality has got 4 or 5 types, I guess. One is wild guess. You just pick from the sky based on your understanding and equation, etc. Then second is literature data. Third is I guess experiments, lab scale. Then industry data. So those are more you going further, preciseness increases. So that you know, in this case I can say 5 is data quality highest because you get the measurements from the industry. And not only 1 year, over multi-year, longer term, awareness technology or new technology, which year. So it's quite, so with LCA problem is that data collection takes a lot of resources, time, money, etc. So that's where the trick is. But if you have nothing, start with something, you know, and then slowly improve. That's the way. Does that answer the question? Alright, so I think, I'm not sure we are going, so basically look at that at the moment, right, carbon all, you cannot do much here. All this technology is what you have carbon, so that, and then as yesterday, food, thing underground, gas underground, then first that's you can make coal from mine, that's the same coal, 2 hours, 3 hours, 24 hours, type, we around that coal or bio we call it sustainable, something like that, you can make it. But that's within a day, whereas nature took millions of years. Black coal, 3 years underground, you know, it can achieve. Brown coal, Australia has not. We've got our estate will come from Melbourne. It comes from brown, and the rate to about 60-70 million a year is that amount for 500 years. People just drive from Melbourne to our, you go down or you get big amount of coal. So brown coal, but because brown coal has a lot of ignite, what we call some low quality. So coal, if you take black coal, good quality, you know, high, ash is low. At the end of the day, if you burn it, because it has got 2 functions, isn't it? Reductant and heat. So generally heat, you carbon, you combine combust with oxygen, you become CO2. There is no other option, and you get heat. Even as a reductant, you use carbon, and the other one, if you use electricity, even electric arc furnace, use a lot of electricity. How you get electricity? Ultimately, same thing. The carbon somewhere is combusted, and that's what your scope 2 emission. Because the electricity you purchase, but that someone is burning coal to make that electricity. So C plus O2, CO2 plus heat, and you will take the heat, but CO2 you cannot abate here. So anything with carbon-based system, hard to abate, isn't it? I mean, you can make that cost efficient plant, this and that, small bits and pieces, but ultimately CO2 will be CO2. There is no other choice, and we saw that on how it is going up around the world. Now, one option they are talking about iron is steel plus CCS. You have heard about CCS? What is that? It stands for anyone in the back? Carbon capture and storage. So that was, they say that from the blast furnace, kind of top of the furnace, when the gas is coming, they will capture carbon and then stored underground. It's still good. You think that concentration is high, isn't it? What's the genuine composition of CO2 in the top gas from the blast furnace?
It is around 20%.
20%. So it's better than power plants. Do you know power plants? Anyone power company is here? What's the policy? What's the composition? What's the composition of CO2 on the stack of the power plant? 10%, 12%, maybe at best. Yeah. So at least. Sorry.
6-7%. Increment of megawatt.
Also, what's the quality, etc. Yeah, that's right. So 7 to 10%, whereas the steel plant is maybe 20% plus minus.
Yes, 20%.
So if you capture, it has to be pure, right? More pure, because otherwise that. But initially, it's not pure, as you can see. The power plant is pretty dilute. Steel plant a bit better, but it's still dilute. So what the capture plant do, they use that gas and send to the columns of various amines. We have done some work, and I did some life cycle assessment and technical economics for the cost of that. So if you go through, then we call it that those layers will capture CO2, and then bottom gas will be 99% CO2 rich, okay? Almost 100% very, very pure CO2. And then other side you get lean gas, and then you recycle and make kind of clean CO2 stream. So then it's still gas. You have to then pressurize it, and then you have to liquefy it, because you have to transport it somewhere to inject, because you can directly inject in everywhere, because injection underground is not easy job, number one. Second one, there are certain geologies you can inject, because in the future, while you are injecting, it will be there for forever. That's the understanding, really. So if it leaks, then that's another problem. So you don't want that. So basically, and also whether people like it or not. So so CCS research started for a while, but there is not many CCS commercial plant work. There are few in the world, but small scale, still probably I would say 100,000 ton per year or few 100,000 ton per year, not more than that. So now, because of that, why is that? Because as I said, if you have a power plant, I say CCS is a technology you include. So you have to first capture it, you have to then enrich it, then compress it, liquefy it, transport it, store it. So all these ones fix energy, right? So your power plant, based on our calculation, will 10% energy will be used for all these activities. So you are probably say 27% or 30% efficient. It goes back to 20% efficient. So what is the next CO2? Ultimately, why you are doing so much stuff, and what's the net gain, right? And also cost involvement, because those amines, some of the amines are not very easily related. So it's a quite complex task. So next thing, people started with CCUS. Have you heard of that term? What is it? So I'm going to time. So you guys find that until 11 now. So you can basically. So what I was going to say, another option, utilize. Then suddenly big surge of research on utilization. Instead of underground, because that's so much CO2, we have to do something. But on the other hand, if we can utilize it, actually in Australia there is, I think a lot of stories comes like that, because in Australia it's a thing called, so because any technology you develop, it has to be first technically proof of concept in your lab, right? It should work. Second, your economically should work, right? Economics should work. Then third, what you call environmental, like LCA. So all these ticks, you pass everything. Then finally, you're going to implement the project. People don't like it. So that's the whether it is good enough, very good, but still people don't like it. So that means political people. So essentially, the politicians has to be on board. So in Australia, we have a parliament like India. We have a parliament is two layers. One is called People's Representative, MLA, Member of Legislative Assembly. Another layer is upper house, two houses. I didn't have any understanding of Australian politics because I am not a politician, I'm a scientist. So in Australia, there is a program called Scientists in Parliament. So essentially, they pick scientists and they take every year, it's a yearly event. So I was, and it's a competitive kind of, so they take those scientists who are bright or has a future. So 2009 I was sort of picked up, I got successful. So that part of that one, you go to Canberra, Canberra is our capital, and we stay 1 week, and they connect with parliamentarians, mainly MPs basically. So I went there, talked to the people, and I saw, because you go to the session, parliament debates, etc. You understand about how politics work, etc. Quite interesting. And obviously, that opened my eyes how politics works. So, but I got that understanding that any technology developed, the politicians has to be on board because they are the connection with the people. So they can convince people because they have the better influence on the people that okay, this technology is good. People will like it. If I go, they don't maybe trust. So although they trust scientists, but in a kind of indirect way. So anyway, so I had that one of the parliamentarians. He said, Dr. Naushad, you were talking because that time I just was very motivated young scientist. CO is a big problem in the world, this and that. So we were having a one-to-one session. He said, is there any use of CO? Can you use it? So much thing, so much CO. I said, yeah, maybe. But I didn't know about utilization research. That was not that time is not strong. And then slowly research started. And now actually CCS, you can see more CCU research now than CCS. And the reason is that because you have got plenty of CO2. I was in Japan, we have a lot of work with Japanese also. So that's if you have CO2, you get hydrogen, you mix them up, you make more hydrocarbon. So essentially you cycle. So if you make, say, we call it synthetic gas, so natural gas CH4, you can artificially make it. So basically CO2 is called methanation. So basically past CO2, there are plenty. I think steel plants will love to get rid of power plants. So you got that one. If you make some green hydrogen, mix it up, you make essentially methane, and then you can start again. Even you can make diesel. So one of the military, probably defense applications. So they like, for example, they have a base in the middle of nowhere, right? So carrying diesel is very difficult for them. So if they can make some hydrogen there, they can immense CO2 you can get from atmosphere. They will direct capture because previously we used to call this kind of power plant. Even they are capturing from the air. It's called direct capture. Have you heard of that? So you've got a lot of technology colleagues are working on. So you can capture CO2 from atmosphere. You can capture water from atmosphere also. You can make obviously solar and wind is there. You make fuel there. And they have got billions of dollars of assets like fighter planes or whatever planes, ships and everything. They are used to diesel fuel. Suddenly you cannot get it. Even diesel fuel, some people say, doesn't matter climate change, but we forget about that. It's a finite resources. One day it will run out. So they need to have those solutions. So CO2 utilization, that's a good concept. And actually I was, as I said, I was in Brunei last week. And you go to the plant, so that is the Brunei Methanol Company, 2,500 ton methyl alcohol methanol they produce, and those actually that comes out of India, they export. So Brunei Methanol Company, and there is a fertilizer company. So particularly methanol company is all natural gas, and so I never been to a methanol plant before. So this time I went, and the CEO, the chief executive, he gave me food himself because it's a privilege. Myself only and another gentleman from our high function. So two of us. It's very hot, like hot weather in that part of the world, no winter, and we are going to the plant. So he showed me, so three of us, and he was a very nice, warm person, explained everything. He's from Colombia, I think. He used to be a manager or plant operator there, chemical engineer, and now retired and become the CEO of this plant. And I think the other plant I went, the CTO is a Bengali person, as I yesterday I spoke. Anyway, so he was explaining everything. It's a very clean plant because in gas plant you don't see much really. It's a very nice, neat, clean plant. So now they are talking about they will have a plant where you can feed green hydrogen and make green methanol potentially. So that's possible also. So this sort of thing suddenly came about, and you need CO2, and plenty of CO2 is there. There is the LNG plant there. LNG is producing, when you make gas, you make pure, good concentrated CO2 also, like your steel plant. So CO2 is plenty around, and we used to think it's bad, but something seems like it's not, maybe not that bad. So that's CCS and you added. So maybe that's one technology, current conventional technology plus CCUS, but it has to be cost effective. And again, we have looked at that, as I said, it has to be net CO2 footprint has to be low. Okay, so that's the thing. Haisana, anyone knows Haisana? Yes?
Gary
Gary.
suggests.
So who is that, Japanese or European?
He is an European.
European based technology, right?
Yeah.
Hydrogen based, is it? Or coal based, but they they give high excess high oxygen or something, or how what's the
Oxygen.
excess oxygen, isn't it? So that's the way I see. So I'm not too much familiar with, but I heard a lot, and I know that that's relatively low CO2 process, is it?
Actually, direct fines would steam.
Okay, that's another better benefit of that. Okay, and then again CCU, I guess DRI. I don't know what are these people, biomass. So we discussed these are the carbon based, but we say biomass is, again, there is a story that biomass has to be sustainable. Otherwise, biomass would not be, I would consider that because biomass is, it's a cycling CO2. So after 8 years, plant are cut, or you harvest the plant, but you have to replant. If it is not replanted, then it's not make
सर
sense.
मोबाइल शॉप तक थोड़ा लो करिए
So,
रिकॉर्डिंग में आ रहा है
all right. Okay. So now, then another one is electricity based system. Actually, anyone knows about molten what they call molten oxide electrolysis? That's a direct, isn't it? Can you explain that?
Yeah. You want to go?
Yeah.
It's a Boston Metal company which has invented this
Boston Metal,
technology,
yeah.
wherein the liquid is kept in a bath, and you apply electricity, therefore it gets electrolyzed, and you have separation of slag to metal. So
See, it needs a lot of electricity, right?
yes,
It's
and
like
high
aluminum.
energy intensive.
Like L03 dissociation to produce.
So aluminum melting, yesterday I said it takes a lot of electricity and 1 ton of aluminum. Can you remember what was the CO2 footprint if you use coal-fired power plant?
28
Four,
times.
so
28 times. 28 times.
So if you do that way, it will be same.
है ना वो तो
It's actually successful when you have exactly, that's right. So cheap electricity and green renewable electricity, then potentially possible, isn't it? That mean, yes, sir.
So the key scientific phenomenon behind this electrolysis is it's a transport of oxides and ions at high temperature. Therefore, this can be also applied to contemporary technologies like EAF. You want to separate iron from the slag. You can do it with this kind of metal oxide electrolysis.
Yes. So I think there are people who are working on, and I know they have advanced quite a bit now, isn't it? They have got a
Commercialized.
plant commercialized Boston technology based. They have got other magnesium, various other technologies. They have got similar line, I guess, using similar kind of concept. Yes, Professor?
Actually, in this molten oxide electrolysis, the most important challenge is to create a molten oxide slag actually that should be created at a lower temperature and which should be capable of continuously dissolving the iron oxide into it, like the way we are doing in the process of aluminum extraction. Basically still the research work is going on, but there are two major challenges. One is what should be the ideal material for this section of the electrodes and design of electrolyte.
And this high temperature process.
Yes. One of the possibilities that could be that, for example, for steel making slag, that is the CAO, FEO, SiO2 system having the melting point in the range of 1600 degrees centigrade. The similar kind of system, but it should have other good electrical thermal conductivity properties, and that can be used ideally for electrolysis process the way we are making it for aluminum extraction.
That's right.
So I don't have much detail about it, but I think a lot of research work has been done by MIT, and that was subsequently translated into the
Boston technology.
by Boston Institute. And I think one or two places in Japan also some research is going on, but they have used different systems. of electrolyte, like barium oxide and something like that, but they have this different system. So still it is an evolving area, and I think it requires building the capability in terms of initiating some research work. I think IIT Bhubaneswar had already submitted a proposal.
I think there is a news around
They
this.
are looking for funding for it.
Recent MIT graduate had done some work on this. There was news on this.
Yes, because
Same
MIT was behind that one, those metals, yeah.
Yeah,
So, but still, I think replacing blast furnaces with that one is long way to go. I don't think kind of, nobody convinced me that way, but
Mass
obviously
production
the future.
Mass production is far away.
Yeah, far away, so that's right, at least that we can do. But on the other hand, we cannot rule out, because it's a mix within the technologies. That's the message, that's not one technology. Some of them will come, some of them will take time, but at least it's we're optimistic. No hope is there. It's not like that. Right? So that's what we talk about. And you see the technology type. We're talking about biomass, CCS, US maybe, and then let's look at hydrogen, because that's my interest. And I think because I'm a hydrogen person, as you know, let's go. So obviously hybrid, course 50. That other ones. What is that? Green high. I think all these, that hybrid is most prominent, I guess, in the news, but others are, I've not seen too many, but people are working on, right? So that's but one thing is that, yeah, it's not, I think for hydrogen steel making, my feeling is that key challenge is to produce enough hydrogen at cost. So it's more hydrogen production than using the steel.
They produce the green hydrogen.
Yeah,
Not only the hydrogen,
not
green
only
hydrogen.
green hydrogen. So that's the challenge. So when the steel people come to me, I said, don't worry, challenge is upstream. I mean, challenge is to us, because getting a electrolyzer technology, getting low cost electricity. If you can sort that out, rest of them sort. So actually, rest of them will be sorted. So actually, we have got a green hydrogen techno-economic, and if you say mid-rex plant, try to put all these numbers, it's not that far. I mean, if you have a $2 per kilogram hydrogen delivered, if you can, because our target is by 2030, $2 per kilogram, if you can get that number, it's possible to make steel. So, but on the other hand, there are other issues we need to look at here. So I think that's a lot of people do not realize that they think that downstream problem is not. It's the at scale, large amount of hydrogen production at cost, green hydrogen. That's the challenge. Is that, do you agree with me? With most of the people here, I guess.
From your yesterday's story of Brunei, you said that there are high forests, like large forests are there. So, do you suggest any solution to use that forest land or forest material, wooden?
They think they have a lot of biomass. Although
for the biomass.
Yeah. So Brunei itself is a small country, but around Borneo Island, Indonesia, Malaysia, because it's all agricultural country, they have a lot of biomass. So I think initially biomass is their priority. But again, biomass, I said that you have to collect large area, collection cost, put in one place, storage, drying, making carbon, put the carbon in the, it's a kind of.
So are they thinking to go towards the biomass, or they don't do?
Oh, so anyone?
No, that Brunei Island.
They're seriously thinking about biomass.
Yes.
Just, I have one question.
Yes.
What should be the ideal candidate to be used as a biomass? Because in the Ministry of Steel, actually, there were several proposals which were suggesting to cultivate bamboo trees.
Dedicated biomass.
Yes, bamboo trees on a continuous basis, and it is having some life cycle, and then so basically they are going to, I think, suggest that a huge chunk of forest land in India, in central part of India, where this exercise can be carried out. And some of the steel plants have, I think they have claimed that they are already using biomass. They have developed something in that regard. But just my question is that for a long-term sustainability related solution, how much feasible it would be to go by biomass route as far as this reduction in CO2?
Exactly, yeah. In 2025, if you are talking about biomass, now the sustainability question will arise now. So we have to think something, some cleaner technology.
You know, if you look at the biomass story, initially they call it, biofuel. First generation, second generation, third generation, algae based, and also Brazil. It's a prime example of using biomass for steel making. They have dedicated plantation, 2 million hectares of eucalyptus. Eucalyptus comes from Australia. So wherever we go, we see eucalyptus trees. Actually, there's a lot of people in different countries. They never heard of the country Australia, but they know eucalyptus. So and there are 6 600 species, and yeah, so I sort of have been to various parts of Australian forest, and I saw that one. So maybe those sort of dedicated fast-growing species, and but land availability, processing, these are so many issues in between. Yeah. So better, I would prefer.
They have developed agroforestry concept.
That's right. In Brazil, they have dedicated plantations. ArcelorMittal has that one.
It's
So
like agriculture.
So it's
You
a
produce crops.
7 years, 8 years, and a short rotation. To be honest,
You take a crop basically.
but
Similarly, agroforestry.
to be honest, biomass area, only area there is a lot of people working algae. You know that one? Algae is kind of sometimes a lot of algae produced in the sea or ocean or something, ocean floor, and they get kind of wind takes them on the shore and they collect, but it's still hummus. That's kind of fun. And algae problem is that because it's a very difficult to handle material, drying, you dry with centrifuges and that's a lot of energy. Because all these areas, I have some way, 1 year to 2 year I work, or some students work, or colleagues work, I have a bit of suspicion of how long, how time we can take that far and cost effective. So, but I'm a big believer of hydrogen, but some people might argue that you need a lot of energy, where that electricity will come from. So that question we need to solve. And that's why that's that question of production. So because if you use amount of electricity asset to produce that amount of hydrogen to replace coal in the existing plant. So one we're talking about 2 million ton of production every year, isn't it? So it's correct. It's all that. So I think that's any comments so far about this? I think I've got the finishing, I guess. This is so various technologies could reduce emissions, maybe through alternative feed stocks, and we discussed about that. And what is this one? I like this one. I don't know about this one, I don't want to too much, but this is CO2 carbon emission kilogram of part of hot metal. You can see that, right? So this is starts with 500, 1000, so when 2 ton of CO2 per ton of steel, 2.5, 3, even 3.5. So they are talking about here, this is carbon or coal based, I'm not sure why that's high. Maybe they have included everything, life cycle basis. And so what you look at that, this is blast furnace here, this is 1.5 or 1.8 seems makes sense within the 2 point gas sort of range. I think that's the correct, right?
That is okay.
So they're talking about say most of the GRI or EF side 0.5 ton of CO2 per ton of steel makes sense probably. So you can plot like that. So what again somebody has done it their own calculation, and behind I think calculation formula sitting, you need to develop your own and see where your technologies and your scheme of things, and then you can recommend the strategies. That is the way to go. Make sense? So I think I don't want to we explain previous ones. Most of them you can do it like that. So, but anywhere between, I think with hydrogen you will be around this mark 0.3, 0.3, I believe, for hydrogen here, right? So I guess the hydrogen technology that's I told, I don't know, Boeing, that's a kind of big extract furnace, it's a shaft furnace, and this sort of furnace is available in India, right?
It is fluid-based reactor.
Okay, so and then you produce steel, produce the same deal, but you need electricity, you need water, and you need hydrogen storage. And hydrogen storage is another. In this case, you can see that underground storage. There are many ways you can store hydrogen. For a steel mill, I don't recommend too much storage. I recommend take it, produce it, use it. Because hydrogen storage is another challenging area. Okay, makes sense? And this is another, you can see that one, green steel capacity at the moment, reducing gas, mostly hydrogen, natural gas to hydrogen, commission here, and whatever various comments. But essentially look at companies, green steel, SAP, hybrid technology, they talk about this Hysen Group, I think, ArcelorMittal, various Liberty in Australia. I believe, because I had communication connection with these people deeply, still because they are taken over by government, and I think these plans still go ahead because in South Australia, you have got very good solar, good wind, you mix them together, it's like a normal power plant. You can make hydrogen cheap. If you, I think I don't know, you have got a lot of NTC or thermal power plant people here. Anything, if you have a 50 megawatt power plant, but use, coal storage, handling, dust, etc. You go to a 55, 60 megawatt solar plant, although it's not the same amount of electricity it will produce. I've been there, no one there, not a single person. If you want to take a selfie, I had a good thing that I had a PhD student, I said take a photograph, otherwise you wouldn't even take a photograph. no one is there. So it's a different world. So that's the benefit. I mean, if you can make a lot of electricity using solar wind, no one is there because you're not burning anything. Once you build it, that's it. You forget about it. Continuous electricity will come and that's it. A little maintenance, but it's not a big deal. So then that one, and then power steel, they're talking about hydrogen. I told about that story of the professor. So that kind of image, I believe that this is CCS obviously. So that capture and going through that, and either you store it or you can add utilization. So that's happening also. And this is a bit difficult to see this slide, but you say there are various energy technologies, coking related or carbon related, sintering related, what you can do, pelletizing, what you can do, blast furnace, what you can do, the oxygen furnace, electric arc furnace, and hydraulic mills, and even carbon capture storage. So they have got a big kind of each one. For example, if you look at say coking, high density, high thermal conductivity. So those sort of areas they are working on. So maybe blast furnace, oxygen enriched combustion technology for hot blast stove, oxygen enriched combustion technology for blast furnace. So this kind of thing, I'm not going to detail, but you can, I think we will supply these slides anyway, right? And you can look at that and pick your strategic kind of from evaluation that this is the way we should go, and we should prioritize, and you can tell your management that this looks like a different way. So I think I want to move from, if you look at the company's GHG emission, you see that one, that's one of the highest, more important and less important, but this is one of the key area companies report that we need to know, and there are other things that companies need to know also. The part of GHG emission is one of them. And we are talking about scope 2, scope 3, we discussed yesterday. There are lots of software, and we discussed maybe not now, we'll do it later. And this is our kind of evaluation. Avash did that one, we can come back to a little later. That how many tons of CO2 from mining, processing, sinter, pelletizing, that's a total. And blast furnace, DRI, basic oxygen furnace, that's a DRIF. I was talking about 0.6 maybe, 0.5. And you can see the difference. The total is, this one is the DRIF route, this one is the biomass integrated, I think. And that's our normally true. So that's our evaluation. So that you can reduce significantly, there is no doubt about that. So yeah, renewable, reductant, heat sources and electricity and complexities need evaluation. It's not easy job, lots of challenges. Means lot of opportunities also. Biomass utilization to DRI, potential to decarbonize, use of agricultural residual first to waste as a biomass use, the availability collection system, sustainability, biomass harvesting and critical, adoption of biomass steel leadership will lead to competition with current other alternative uses, because in Australia, in everywhere, if you want to take biomass out, it has got certain uses already. So what's the, what we call opportunity cost of the biomass? The cost effective production of charcoal from biomass at a scale is a key challenge. I think that's my view. So I think, yeah, I sort of, that's our hydrogen car. I don't know whether I showed yesterday. And he's our high commissioner at the moment in Delhi. And you know, Dr. DG, yeah, DG for CSR. And I visited also CSR Singapore. They have some work on coal utilization of coal various ways. They are the main research body in Australia. They are very so yeah, they are doing some work, I guess. I think I will finish it here this morning. Any comments or questions?
The infrastructure cost means to set up a hybrid system like solar and wind based power plant, and for setting up on coal-based power plant. How much
What's the difference?
infrastructure?
So infrastructure operating cost nothing, but initial investment is higher for solar and wind.
How much? Like 5 times?
At least 3 times I would say. But because you have got capacity factor low, then the solar is 20% capacity factor. So that's what we are doing with the green steel costing. We have 2 scenarios. One is that somebody have that plant offer giving you electricity at a price. Okay? If electricity is the same price you are getting from the grid, same thing, as long as they can provide that. Other option, you invest your own power plant, like captive power plant. But on the other hand, you don't have to pay the profit for the person so that you can get a lower cost. I think investing capital, what is called vertically integrated company, which is most of the Indian scenarios, in countries like Australia, they have always different power plant owned by someone, the processing plant owned by someone, iron ore company someone. But here, if it's a Tata or any company, have that all vertically integrated fixed capital. That's my view. And that's what evolution is. Make sense? Any other? Yeah, Professor Acharya?
Can you hydrogen.
Okay,
You
so,
have some reserves and
okay. So not only Australia, actually we have done, if you Google techno-economics of natural hydrogen, so our group, the first pioneer work has published just recently, one of my team member, expert in natural hydrogen. So what is the, so natural hydrogen is like gas, okay? So but how much hydrogen in some places there are hydrogen available in the field, gas field kind of that. Not only hydrogen, also helium. So helium has got a market. So if you extract hydrogen, that's relatively cheap because you are not using electricity, etc. It's already there, but you have to enrich it. And depends on the concentration like gas fuel. Because hydrogen has low concentration. So sometimes we are saying that maybe you sell helium as a byproduct, reduce the cost also that way. So natural hydrogen, but it's very early stage. There are a few companies working on US, in Australia, I know. Other Asian countries they are looking at. Many countries may have actually natural hydrogen under the ground. But we need to explore that, number one. And good thing is that all the natural gas companies, they have explored quite a bit. They have a lot of data. Potentially that is a trace or indicator for natural hydrogen. That's one way. But I think that in US apparently current administration, I know they are favoring because there's a big project going on. So yeah, it's another topic. Potential natural hydrogen in India, I believe the gas companies will be looking at. So that's another way to start. And I think CO2 is relatively low because you just pump material and then process it. It's not necessarily that high CO2 loading. So
maybe a policy shift.
That's
and
right.
infra building could help.
I'm sure that, but not many capability because you need good geologists, you need good kind of extraction, especially like say chemical engineers. A lot of gas industry can come into, but it's a different kind of way to extract rather than natural gas. It's quite a high concentration, whereas green hydrogen or natural hydrogen is very low concentration. That's the one thing. Does that answer your question? So please explore our paper. I think you will be wealth of knowledge in that paper. At least we have compiled and published in International Journal of Hydrogen Energy. You can Google it, that natural hydrogen and HOC. At least we get it. Anything else?
Just my question is regarding space constraint, like India, like country, that how much space is required to create a solar power plant of reasonable capacity as needed by the steel industries? For example, for the electricity which is required by 1 million ton of steel plant, and we want to run it just based upon solar energy only, then how much additional space is required to produce either solar energy or wind energy or any other renewable energy?
There are lots of studies like that, and it's quite easy to do because solar energy is, I don't know, is that 1.3 megajoule per meter square, isn't it? That's the incident energy, and that extracted, converted, ultimately same thing. Wind is kilowatt per meter square or kilowatt hour per meter square, depending on mast height, depending on wind speed. So I think wind doesn't take space, wind goes up. I sometimes favor wind if there is a wind. Solar needs land, and any country has got a land is a precious material to think of, thought of. But for example, countries like Brunei, they don't have any land at all. Still, they are thinking about rooftops, maybe government rooftops. Some of the buildings may have some, but weather like this, you wouldn't get solar at all. How do you run the plant? And so you have to have some storage, maybe in the form of hydrogen or batteries. That's one thing. Second thing is floating solar. A lot of talking going on. I heard that in Delhi, on the canal, they are going to come up with solar panels or something. Is it ISCO?
At ISCO we have
ISCO, I saw that
4 megawatt.
So it's covered pond.
Yeah,
It's a floating kind of solar,
floating.
but that's one kind of floating. Another floating is in the sea. So it's I've seen in Singapore, and Chinese are doing it. So it's a doable, but it's if it is sometimes in a big lake or river system, if it is stable water, no problem.
We have in our dams.
Dams, right, yeah. But sometimes, and also that reduces the evaporation of the dam also, isn't it? Reduces the evaporation because it's covered, right?
So half area covers.
Covered. So but if you say there is a chance of taken away by current or so there is a bit of risk, but I think technology is there. It's a little bit expensive. I don't know how your one, but compared to say land, but on the other hand, you can utilize the water bodies, and there are a lot of water bodies, even a lot of vacant lands. I think we did one study on the railway, waste railway land. So beside that one, there is potential. So everything thing we have to think about. Nowadays there is
Well, recently Switzerland did one thing, the railway tracks.
Railway tracks
The
covered
space
in
between
that.
the railway tracks, they have covered with their.
so those sort of spaces we can use. The clever way those countries have land restriction. In Australia, some places have not only land. One place I've been to, it's like one district, and the farmer, the described, he said I've got 300,000 acre land. I said, what are you talking about? How do you manage? He said, I have got a big truck and four-wheel type things. It goes all around, and I said, you must be very, very rich. He said, no, it's $50 per hectare. so it's not necessarily that, but not very usable land, but that's the one thing. So I think the technology there. Another thing is for agri photovoltaics. Have you heard of that?
Yes.
Agri. So you can have the cultivation at the same time you can get. So people coming up all sorts of clever ways, and I'm sure that.
But the sustainability part is challenging. That energy demand will be required for running the system, and the space we have, there's a problem. Mismatch.
Because I can be very good advocate for solar, but when those questions are asked, solar has no emission, that's true. But on the other hand, what about the land? Because land has got some other uses, isn't it? So it's a balance, trade-off, and that's why the key message is that one technology is solve the problem. You have to